Alright, it's Chili here, and it's time for Lesson 8 of the Beginner Game Programming Tutorial. This is going to be a long episode. So, first things first, we have to go over the homework for the last episode. Now, the task in the previous episode was to make the cursor move around the screen. We were going to add a second cursor to our application, and we want to make it move in a predetermined pattern around the screen here. Something like this. Whoa, getting drunk here. Something like this, but only a little bit straighter. There we go. Right? I want to move along the top here, then move down along the right hand side, then move left along the bottom, and then move up along the left hand side here. So I mean, the first thing you're going to want to do is you're going to want to get another reticle, right? That's very simple. First we need another set of position variables. So we'll call this one int x2, int y2. That is for our other reticle. Then we're going to initialize them. So we'll set them to 100, 100. And last but certainly not least, we need another set of put pixel calls in order to draw our second reticle. Call this, we'll name this draw another reticle here. And we have to replace all our y's with y2s and all our x's with x2s. And if we do that, we should get two reticles here. One of them moving by our direction keys and the other not moving at all. Okay, so that's part one. Part two is getting the damn thing to move. Now it's easy to get it to just move. All you gotta do is go somewhere and jam in, say, x2 equals x2 plus 1. And the bugger will, sure as hell the bugger will move on his own. But he'll just keep going in this direction, and then that's no good. That's not what we want at all. So we need to be a little bit more selective in how we move the cursor. So if we break the problem down here, we've got 4 different regions of movement. Along the top, we're moving to the right. So here we want x equals x plus 1. Here we want y equals y plus 1. Here we want x equals x minus 1. And here we want y equals y minus 1. Now the trick is how to write an if statement to determine when we are at the top, the right, the bottom, and the left. And the answer is to look at the coordinates of the cursor or the reticle when we are at these different regions. So when we're at the top region, the reticle's y coordinate will always be 100 in this region here, or along this segment. And along this segment, the x coordinate will always be 700. Likewise, along this segment, the y coordinate will be 500, and along this segment, the x coordinate will be 100. So using that information, we can write if statements to determine which segment we're on, and then update the position variables accordingly. For example, if x2 equals 100, then we are on the top segment. Shit, that's wrong. y2. y2 equals 100, we're on the top segment, right? And if that is the case, then we want to increase x by No. By 1 every frame. And when we're on the right hand segment, x will be equal to 700. And in that case, we want to increase y by 1 every frame, and so on. Alright, here is the finished product. Let's build this mother. No problems, and we'll start debugging. Okay, so our reticle is off. Now the question is, will it make a turn when it gets to the corner? And it does. So as we can see, this code here is working out quite well. Now we're on the y2 equals 500 portion, and we are subtracting 1 from x2 every frame. And finally, we're back on our way up. So this code works. And you might think, well, that was easy. No problem. But personally, I would give this solution a B or a B+. It's close, but it's not quite there. And the reason it's not quite there is because this cursor isn't actually traveling on a perfect rectangle. And the reason why that is because when it gets to the corner, it actually skips the corner. It doesn't go right to the corner and then up. It goes right before the corner and then skips diagonally and then starts going up. Now you might enter this code and have run it already, and you might be saying, I didn't see that. And that's because it's moving, the pixels are too small for you to be able to notice that small little difference. But believe me, that is exactly what is happening. Let me just show you on a little diagram here. Let's say this is our grid of pixels here, right? Ooh. 2, 3, 4. Okay. So here we have this is the X, this is the Y. 101, 100, and 700. So let's say our targeting reticle is at 699. Okay? We've just drawn it at 699, and now we are updating to the new frame, so we're going to update its value. So we go to the reticle moving algorithm here, and we check if y2 is equal to 100. Is it? Yes, it is. So that means that we increment x2 by 1. And if we increment x2 by 1, our new value will be right here. Yeah? We just moved from here to here. So as things stand here, our reticle will be drawn at 700, 100, which is what we want. So what is Chili's problem? What's he talking about? Well, look at the next line of code here. Now this is for movement along the right-hand side going down, right? This is for this movement here. And it's checking if x2 is equal to 700. And, well, okay, yeah, now it is equal to 700 because we just updated it. And so, okay, in that case, we're going to move y2 equals y2 plus 1. We're going to move the cursor down 1. So wait a minute, in one frame now, we've gotten 2 updates. We moved to the right, but now we're also moving it down. And what that means is that in this frame, the cursor will be drawn here. So in the previous frame, it was drawn here, and in this frame, it's drawn here. It never gets drawn in this position. And that's an important skill for a programmer, by the way, being able to look at the code like this, go through it line by line, and analyze what's happening to the variables. But I don't know, maybe you don't believe me. Maybe you think I'm still pulling your leg. Well, I am going to prove it to you. And the way we're going to do that is we are going to debug this code. We're going to run the debugger. So I want you first to set the release manager, set it to debug mode. And then I want you to go over here to this area beside the text editor window and click. And this will put a breakpoint in our program. What this breakpoint does is the debugger will stop here whenever it reaches this line, and it will let us examine the variables and step through line by line through the code. So we've got our breakpoint, we've got our configuration set to debug. So do start debugging. Alright. So our program has started and we have entered our compose frame function and run down to our breakpoint, and then the program has broken execution and is waiting for our command. So in this state we can look at the values of our variables. I want you to go down to this window here and check go to the locals tab. And here we will see an item called this. Now this is actually our game object. Look over here, if you look at type, it says game. So I want you to expand this game object, and you can see all the member variables of our game object. And here is our x2 and our y2. This is what we're interested in. Now, we can step through this code line by line if we go here to the step over button. So click this button and we will step to the next line of code. So we've stepped inside this this code block of the if statement, because the test y equals 2, y2 equals 100 is true, right? It does equal 100. So that means that we entered this if statement. And if we step again, we see that the value of x2 has updated. It is now 101 because this line has incremented it. And if we step again, we can see that we have skipped over this code block because x2 does not equal 700. And if we keep stepping, we can skip over, we'll skip over these two if statements, and then it's just drawing our pixel. Now, I mean, we could continue to step, but that will take a long time. So what we can do is we can press continue, and it will just keep continuing until it hits our breakpoint again. So we hit continue, and right away it comes back to here. And now we are on the second frame. And if we step, we see that our x2 has once again increased by 1. And stepping, we're skipping again. So we can continue to continue, and our x2 will continue to grow. This is our reticle slowly moving right across the screen. Now, if we keep doing this, it will take forever to get to 699, which is the value that we're interested in. We're interested in analyzing what happens when x2 is equal to 699. So, what we're going to do here is another thing we can do in the debugger, which is we can directly change the value of our variables. So if I type 699 here and hit enter, now x2 is set to 699. So it's as if our reticle is right at the or right before the top right corner. So now let's analyze what happens at 699, 100. So as usual, y2 is still equal to 100, so we increment x2. But now that we've incremented x2, it is equal to 700. So that means that instead of skipping this if statement, we're also going to enter this one and update y2. The end result is that we moved from 699, 100 to 700 101, and thus we skipped the corner pixel like I said. So that was a lot of time spent to basically prove to you that this code is not perfect. And also to give you a little introduction to the debugger, which is a very useful tool for crushing bugs. Alright, so we will take off this breakpoint. We can reset our build configuration to release build. So we know that this code isn't perfect. What do we do about it? I suppose there's a number of solutions. I'm going to show you my solution. Now the problem is that as we move along here, once we get to the corner, we immediately enter the region for the next stage of movement. So when we hit the corner, we actually do 2 updates in one. And that's because the next stage of movement follows the previous stage here. So what we can do is we can invert the order of our if statements. We can start by testing for this state, and then test for this one, then test for this one, and finally test for this one. And if we do it that way, there we go. Get rid of this one. Put it here. This one. Here. Alright, I think that's right. So if we test it in this order, what will happen is we'll test for this state, and it will say, no, we're not at 700 yet. Then we'll test for this state, and we'll say, yes, x is equal to 100, and then we will update. We'll move to the corner. But because we've already tested for this one, we won't then again right after move down, because we've already finished this test. So by simply inverting the order of the if statements, we can prevent that 2-in-1 position update, which causes us to skip our corner pixel. Alright, so let's see if this works. Spoiler, it will not work. Let's try to debug it. Or we'll just run it. Okay, now our reticle is moving up and going off the freaking screen. That's not good. Break. Okay, stop. Alright, so something has gone horribly wrong. Can you figure out what it is? The answer is, now that we are starting with our left-hand case test, what happens is it checks to see if x is equal to 100. Whereas before we started our test with is y equal to 100. Now we're starting with is x equal to 100. And it just so happens that this test is also true because we start at 100, 100. So because it hits this case first, it says, yeah, we're on this line segment, and it starts moving up. And it just keeps on going, and that is not good. The solution is to add another condition for this if statement. So we're going to say x is equal to 100 and y is greater than 100. So if we're right on the point 100, 100, it will not enter here because y is not greater than 100. So making y has to be greater than 100 excludes this point here and means only these points down. So the point 100, 100 is not cool for moving up. So if we do that, it will not enter here, and everything should be fine. We'll build a solution. Start debugging. Okay, now we're moving right. This is good news. Now let's see if something else bad happens. Okay, that was fine. Now we're moving down. Okay, so far so good. Now we're moving left. Okay, good. Okay, So it looks like we are safe now. This should be a solution. Okay, no problem, no problem. So all we needed was that extra condition here, just for the start there, for the case of 100, 100, to make sure it doesn't go off in the wrong direction. Now, just for completion's sake, I am going to debug this mother. And what? What's your problem? What's the matter here? Ah, right, I'm at really. See, look at this. Okay, this is what happened here. This is what happens when you try to debug when you aren't in the solution configuration of debug. It won't let you take a peek at your variables. It just all looks like frickin' garbage here. So, you stop debugging, you set your configuration to debug, and you start again. And now, okay, now we can look at our this function. Okay, so let's check the case of the top right hand corner. So we're at 699. We skip this one, we skip this one, we skip this one, and then we update x2. Now we're at 700, 100, and we draw our second reticle at 700, 100. Perfect. Okay, let's try another one here. Okay, now in this case, we are in the case of x2 equals 700. So now we're going to start to move our reticle down, right? So let's see what happens when we set y2 to 499. 499. That's the again, that's the point right before the corner. And we step. We increment y2 to 500, but because our y2 equals 500 test was before this point, we're not going to enter it now. We don't have any danger of entering it and updating the variables a second time. So again, we get to draw on the corner instead of skipping it. So that is that. That took about 20 minutes, and I know some of you, or maybe most of you, didn't really want that much detail explanation, but I think this is important because, I mean, in this case, it was just an aesthetic thing, and you couldn't even tell that it was skipping the corner. But in other cases, little bugs like that, or little oversights, can cause major problems, and it can totally fuck up your program. And you'll be pulling out your hair wondering, why isn't this working? And it's just because you missed one of those little corner cases. That's an actual word in programming called a corner case. It's a special exceptional case besides the whole general thing. So moving along these lines is the general simple case, but at these corners there's special cases. Okay, and learning to see those, to recognize those special cases and evaluate them and analyze them and find ways to work around them is part of programming, like it or not. And you also got a good introduction to the debugger, which is good. Now, let's get on to the fun stuff, alright people? We need to learn some new shit in this lesson. That's why this lesson is going to be long, because we're just getting started. Now, one thing you might have considered is to draw another reticle. We had to basically copy this code down here again. And that's fine. But like, imagine you had to draw like 50 or 100 reticles. Or like, imagine those reticles were, again, bullets in a shooting game. You can have hundreds of those things on the screen. And for each one, copying the same lines of code over and over and over again seems rather wasteful, and that's because it is, and you would never do that in real programming. So let me show you what you would do. If you've got a bunch of code, and the code does, and it's repeated over and over again, and every time it does basically the same shit, what you should do is you should make a function for that code and then call that function every time. So we're going to add a new function to our game object. Actually, we're going to put it, I made a special space here for you guys called the users functions section. Much like the user variable section, we can add functions to our game thing here. So we'll put the user ones in here. Keep them separate from the framework functions. We're going to call our function draw reticle. And it's going to take two values, int x and int y. These values obviously are going to be the position at which we want to draw the reticle. We could give it some other variables. We could also pass it the colors that we need to draw with. Alright, that sounds good. That's what we'll do. So here's our new function. The first step to adding a function to our game object is to what's the word I'm looking for? Declare it inside here in the header file, the H file. And the next step is actually defining the function. Now we'll put it here for shits and giggles. So we type void, and we're saying we want to define a function that belongs to game. So we type game. That's not what I wanted. Then we type this thing, and here we get a list of all of the members of game. And we'll go down here to draw reticle. And wait a minute. That's strange. I'm not getting my IntelliSense. X, int y, int r, int g. That is strange. I'm not doing something stupid here, am I? Pretty sure I'm not. Let's go back here. Okay, I got my draw reticle here. And it's all good, I think. Well, anyways, let's continue. This is ominous, but I am going to soldier forward. Now we need to figure out the body of our draw reticle. And that's pretty simple, right? We just take this code here, copy it, put it here. X and Y are we don't have to declare them in here. We don't have to say, we don't have to say int x, right? Because they appear up here in the list of arguments or parameters. So that means that we can use them inside the body. Now we have an R here. We need some G's and B's. So I'll copy that one and mass paste. Go, 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 go. And again with the B. No. There we go. All right. And that is that. Now we have our draw reticle function. Okay, looking good so far. Now all we got to do is replace this crap with one simple function call, reticle. And our x is x, our y is y, our r is r, our g is 255, and our b is 255. And likewise, we can draw this reticle. Draw reticle x2, y2. We'll just make the second one white. All right. And now, build that mother. All right, success. And yeah, so we got the same deal we got before, except I made this one white, but whoop-de-doo. It's the same functionality, but it's much prettier in the sense of code here. So we've made our one put pixel function, and now we can call this as many times as we want with just one single line, which is very nice. Now, of course, there are other very good reasons for breaking your code into functions, especially when the code is being reused. But we won't get into them now. For now, we'll just say, hey, it's prettier. I like it. It's easier. It's lazier work for me. I can do less work for the same amount of awesomeness. Yeah. So that's making functions. We're going to be making lots of functions. We're going to learn more about making functions, but that's the gist of the deal. Now what we want to do is now we're going to make a lame-ass game with all these skills that we have accrued. So, I'm going to do a little house cleaning here. Okay. What should I get rid of here? Okay, we're not going to need this color shit. So, ditch that. Ditch that. We're not going to need this. The moving reticle code. We'll keep the clamping code, we'll keep the moving code, we'll keep the speed code. We'll leave the draw reticle. Now we'll get rid of this too. And get rid of this. Get rid of all that. Okay. Now, let me tell you what I have planned here. Okay, here's the idea. We're going to make a game, a very simple game, where you have your dude, and you have some stuff, and your dude has to go and collect the stuff by moving over it. And when he collects all the stuff, then you win. Wow, isn't that's a fucking exciting game right there, man. Jeez. Game of the year. I'm gonna put this one on Xbox Live. Alright, so we're gonna need some variables. Okay. First, we're going to need the variables for our dude. Alright. We're going to need our int. We're going to call our dude, he's going to be Mr. Face. So we need his face X and his face Y. Yeah. Now we're gonna... fuck it. I'm not gonna do that. Never mind. That's not important right now. What is important is that we get our variables for our face. So we've just got his position, X and Y. Now we need the variables for the crap that we have to collect. So our crap that we're collecting is going to be poo. So int poo X. No, poo1x. Int poo1y. Int poo2x. Poo2y. Int poo3x. Poo3y. Okay, here's the position of our three things here. Now we need another. We need to be able to keep track of whether or not our poop has been collected. So when the dude moves over the poop, we want to make the poop disappear. And we want to remember that we got the poop, because we need to check whether we've got all the poop before we can end the game. So we're going to make a new variable here, and we're going to make it of type bool, which, if you remember, that's a boolean type. It can be either true or false. So the boolean variable will be is poo 1 eaten. Okay? And we'll do that one for the other two. Is poo 2 eaten, and is poo 3 eaten? And this variable will remember whether or not these poos have been eaten by the face. And I think that's all the variables we need for our game. Now the next thing we're going to need is we're going to need some faces and some poo. So let's get on that shit. Pun intended. So let's make our face guy. We're gonna renovate this function here. Draw face. And our face guy is not going to have different colors. So we'll just draw him at a position. Now this is a reticle. This is not a face. It makes a pretty shitty face. So the question is, how are we going to make a face? Now theoretically, we could write put pixel. We could manually write put pixel functions in here and do a kind of pixel art in code and make a face that way. But that's crazy talk. So for this exercise, I have provided you guys with a little basket of goodies. You'll have to go to my website here, planetchili.net, go to the forum, everything here, and click on Lesson 8 Crap. And if you go here, we'll get a bunch of attachments. So let's go to the face attachment here. And get out of the way here. I'm going to open it. Here we go. Okay. And so now we got a text file with a whole buttload of put pixels. And these are, together, these represent our face. So we'll select all, copy, and we're going to paste these mothers. We're going to stick them right in here. Just plop down a fat load of put pixels. And because I'm OCD, I'm going to select these and hit tab to indent them. You don't have to indent them, it doesn't matter. And now we have our face drawing function. This function will draw a face for us at XY coordinates. Now if you click, this is a lot of code that's just kind of, I don't know, just sitting here, chilling out in the middle of our source file. It's taking up a lot of space. So if you look over here, we got this this little box. You click on it and you can minimize this function. And yeah, now it makes a much smaller footprint on our source code. It's still here, it's still all good, but we don't have to look at it. And that's good. So let's do some shit here. Let's draw our face. We'll put draw face. And we want face X, and face Y. Okay. Now all this code here is for the cursor. And that's not good. That ain't cool. So we're gonna find all of our X's and replace them with face X. Replace all. And all of our Y's, replace them with face Y. Okay, now we're starting to get somewhere. So this code will act a lot like our reticle, but it's gonna move. It's gonna be our face dude now. We got our face guy. Look at me, I'm Mr. Face. And he'll move around, and he's clipped to the window, but it's a little off. He can't get right to the edge of the window. And if we go down to the bottom, he kind of goes off the end of the screen. That's a problem. We'll fix that. First problem is that, just so that you know, up until now, we've been drawing our targeting reticle such that the XY position indicates the middle of the reticle, right? But normally when you draw a sprite, that's all slanty. That's no good. That's slanty too. Damn you slanty sprites. When you draw a sprite, generally the XY positions indicate the top left corner of the sprite. And then you have your width and your height of the sprite here. And that's what we're doing with our face dude. So we don't want to clip to 5. We want to clip to 0. Because we're not clipping this, we're not working from the center anymore. We're working from the top left corner. So we want the top left hand corner not to get less than 0. And for the top right hand corner, we want face X plus the width of our sprite, which is 20. You can see that from the text file here. I say face 2020. That means that this sprite's dimensions are 20 pixels by 20 pixels. So we want the X coordinate plus the width should not exceed 799. I think that's right. Yeah. It's either 799 or it's 800. I'm going to say 799. And if it does exceed, then face X is equal to 799 minus the width, right? And likewise, we go down here, face X plus its width should not exceed the end of the screen, the bottom of the screen. And if it does, then we want to set it to the bottom of the screen minus the height. If we do this and we build this mother, we should get some more reasonable, there we go. Now we're clipping to the extent of the screen. I think that's right. If we go down here, yeah, that seems about right. I'm getting some nasty tearing at the bottom of the screen for some reason. It gets all like freaky right around here. Wonder why that is. I wonder if you guys can see that on the recording. Anyways, yeah, our clip-in is working hunky-dory here. So, the next phase of operations is to slap down some poo. Actually, first of all, before I get started, I did a bad thing here. I should initialize my X and Y values. We'll put this one at 390 and face Y is at 290. So that will initialize our face to the middle of the screen. It's better practice to initialize your variables. Okay, now we need poo. So let's do this. we'll initialize our poo. Poo1x 100. Poo1y is at 100. I need more poo. Must have more poo. Poo 2. And poo 3. Okay, I'm just going to put stupid random variables here. So put 550 for the x and 200 here. And we'll put 300 here and 510. I don't know. So 650. Okay, random position for our poo. Get rid of that comma there. We don't need that. And let's draw. Let's draw some poo on the screen. So, okay. So we need a draw poo function now. So I'm gonna copy this. We'll change face to poo. And I got a phone call. One sec. Alright. Where was I? Oh yeah, I was gonna make some poo. Okay, so we'll add a new function here. Void game and draw poo. Again, my IntelliSense is screwing me over. Go fuck yourself, IntelliSense. Okay, now we need some poo. So we go back to, let me just close this one. Go back to the forum here and download poo. Okay. We want to go open. Yeah. And here's our poo. So we go select all, copy, and then we're going to paste our poo. Let's scroll up here. And I fucked it up. I'm going to select all the put pixels, tab them over, satisfy my OCD. And then I'm going to minimize this function because it is an eyesore. And now we have poo, so let's draw it. Draw poo. And what do we want here? Poo1x, poo1y. And we'll copy that. Paste. 2, 2, 3, 3. Alright. Now if we I was in debug mode this whole time and I didn't even realize it. Now if we start debugging, build everything. Now we've got poo all over the place. Look at all that poo. Oh, go eat the poo. Oh, what's the matter? Eat your poo. Go eat your poo. Don't you like your poo? I made it just for you. Okay, so we still can't eat the poo, but we have the poo. There is poo on the screen, and it is good. Okay, so now we need to make it so we can eat the poo. Let's do that now. I'm going to get rid of these function calls here. I'll leave them, whatever. So, if we got to check to see if the poo has been eaten already. If I think I named my variables wrong here. I don't like this naming here. Is poo1 eaten? That's not a good name for this. Poo1 is eaten. That's a better name for a Boolean variable. Poo1 is eaten. There we go. It doesn't matter what your name is, but it kind of does for me. Poo1 is eaten. Okay, here we go. All right. So if Poo1 is eaten, I'm going to put an exclamation mark here at the beginning of the word. And what this exclamation mark does is it inverts the value here. I talked about that a little bit before. This is asking if Poo1, if not Poo1 is eaten, or if Poo1 is not eaten. So what this thing does here is it inverts the value of this variable. So if Poo1 is eaten, the value of this expression here would actually be false. Am I making myself clear? Basically, this whole thing here is asking if Poo1 is not eaten. So if it's not eaten, what we want to do is, what do we want to do? We want to draw the poo. First, we want to check to see whether our face is in the poo. So, to check to see if our face is in the poo, we need to do kind of collision detection here. So here is our, stop that. Here's our face sprite right here. This is the box, the bounding box of our face sprite. And here's our poo sprite. Poo. Now, what we have to check to see is whether these two boxes overlap. So the first test to check whether they overlap is they overlap, first of all, if this box here, if the right hand side of the box here is greater than the left hand side of the box here. If the right hand side here, for example, if it's over here, if the right hand side is less than the left hand side here, we know that they can never overlap. So we check to see if the right hand side is greater than the left hand side. If Poo1x, no, if face x plus 20, which is our face width, is greater than it's greater than or equal to, I'm thinking here. I'm going to say greater than. So if the face x plus the width, right? Here is face x, and here's the width. So face x plus the width, the right hand side, is greater than the left hand side of the poo, which is Poo1x. No. And simultaneously, face x is less than Poo1x plus 24. Right. That's the second. The second condition is obviously, I mean, if our face is over here, and the left hand side of our face is greater than the right hand side of our poo, then we know that these two can never overlap again. So the left hand side of our face here has to be less than the right hand side of our poo. It can be here, which is still less than, or here, right, which is still less than. But if it's greater than, then these two can never overlap. Alright, so now we've established that as far as x is concerned, we might be overlapping. Now we have to check the y's, and it's just the same shit, different pile. So if face y plus 20 is greater than poo1y, face y plus 20. No, that was stupid. Face y is less than poo1y plus 24. So if we satisfy all four of these conditions, then we can say that the face is overlapping with the poo. And in that case, poo1 is eaten should be set to true. And we're going to draw our poo. Poo1x, poo1y. No, y is big. And then we'll stop this thing. Okay. Now in this case, if they do overlap and the poo is eaten, it will still be drawn in that one frame, but that's only a slight instant, and then the poo will disappear. So it's fine. And after that, because we set poo is eaten to true, we will no longer do our check or draw the poo after it's been eaten because of this if statement up here. Okay. So now we can get rid of this draw poo. And let's just test that out. It's very good practice to write a little bit of code and then test it, and then write a little bit more and then test it, rather than writing it all at once and then trying to test it. Because if you do that, you'll have so many bugs, it'll be just a headache just trying to get it working. Incremental development is the key. Okay, so our poo has somehow disappeared here. And the reason why it has disappeared is because we have not yet initialized our Boolean variables. So we need to do that. We need to get on that shit. So poo1 is eaten. It's false. So we start off with poo1 not being eaten. Let's debug that and start. Okay, now our poo exists. It's being drawn on the screen. But if we move our dude over to the poo, it disappears because the poo has been eaten by the dude. These ones, it doesn't happen because we haven't coded for them yet. But, okay, so eat the poo, poo disappears, all good. Let's fix that shit up for the other two poos. So we'll copy this here. Paste that down there. Paste that down there. Okay, now what I want to do here is do a control find here, and we're going to replace poo1 with poo2. Replace all. Wait, what? We don't want to match whole word. We just want to match partial matches here. Okay, we replaced 8 poo1s and we replaced them with poo2. Seems good to me. Let's try that for this one here. No. Yeah. Find. Replace poo1 with poo3. Alright. And now that we've done that, we can lose the draw poo. We'll build our solution. And it worked. So now, okay, I forgot. Forgot one little thing. Gotta initialize my variables. So poo1, poo2 is eaten, poo3. We have to initialize the poo to the uneaten state. Oh, something bad happened. need a comma here. Gonna get rid of a comma there. And okay, that was fine. That works now. Let's do it. Let's eat that poo. Eat the poo. Nom 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 nom. Nom 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 nom. Okay. So the poo is being eaten. That's great. But we are not finished yet. Now we need to, give the player some indication that they have succeeded, or that the game is over at least. So to do that, what we're gonna do is first we need a graphic for showing game over. So we're going to add one more sprite to our catalog. So we'll copy this, paste, and draw game over. We'll go to game.cpp here. I'm going to copy this in here. Copy that, paste, draw game over, and again, the chili has generously provided you with a text file. If I can find it here, get rid of that text file. Okay, gameover.txt, which is rather larger than the other ones, so it's going to be quite a few more kilobytes. But download it. Download. Yeah, and open. Again, select all, copy, and paste that mother. This one's going to take up a lot of space. I'm going to position my cursor here at the end. I'm going to scroll all the way up here. Phone again. Alright, okay, alright. So, what was I saying? Oh yeah. I'm going to select all this here. I'm going to tab it. And then I'm going to minimize. So now we have our draw game over. Now the question is, how do we determine when the game is over? Let's use an if statement here. If poo1 is eaten and poo2 is eaten. Wait. No, I need to change that. If not, poo1 is eaten and poo2 is eaten and poo3 is eaten. Do this stuff. Otherwise, okay, here we go. Oh, I need an extra bracket here. Alright, so what this is saying is, well, this sub-expression here is saying this whole thing is true if poo1 and poo2 and poo3 are all eaten. If they're all eaten, this is true. But since we have a not here, that means that if they're all eaten, this is false. So if all the poos are eaten, we will not enter in here. Which makes sense. I mean, if we're at the end of the game, we do not want to do all this poo crap. Now here's where the magic happens. Else. We haven't looked at this yet, but I'm going to show it to you now. Else draw game over at, I don't know, 350, 250. That's not too good. 375, 275. That's about the middle, I guess. Now, what an else statement does is it executes only if the if statement above it does not execute. So if I say if blah, if this is true, then we execute this code here, and we skip the else. But if this is false, we skip all this code here and execute the else. So if you have an if-else construction, then certainly either one of these code blocks is going to get executed. Either this code block is executed, or this code block is executed. But they're never both executed, and there is never a case where neither of them is executed. There is always either this one executed or this one. So if all the poo is not yet eaten, then we run through each of the poos and check to see check for collisions and for drawing. But if all the poos are eaten, then we skip the poo checks and we simply draw our game over graphic. And even if the game is over, we're still going to draw our face. So we'll allow the gamer to roam the screen even after the game is finished. So let's build this, make sure it's all good, and start debugging. So if I haven't fucked anything up here, I should be able to go over here, eat that poo, eat this poo, eat the last poo, and then here we get our game over screen. Game over, yeah. So yeah, that's the game, people. That's the game. It's fairly basic, I know, but it does provide a good way of tying together a lot of the stuff that we've learned up until this point. And we will definitely be increasing what we can do, what kinds of games we can make in the future.
And now a message from the Power Rangers.
Greetings, loyal YouTube viewers. This is your Chili speaking. I have a dream, and that dream is to create a vibrant community of programming students and game programmers. I want it to be a place where programmers can help each other out to get new ideas and further their studies. A place where everybody knows your name and they're always glad you came. Can we do it? Yes, we can. But I am gonna need your guys' help. So today's mission is a little bit different. Today's mission is a shameless appeal for upvotes. So what I want you guys to do now is click on, I'm going to put a link in the description and on the video here. I want you guys to go back to my lesson 1. Shut up. Go back to my lesson 1 and yeah, click the like button here. I realize some of you guys have already liked my videos, and thank you for that. But I also realize that a lot of you guys haven't. For whatever reason, didn't bother to click the like button. I need you guys to come back here and upvote my video. If I can get enough votes for the video, that should improve my rankings in the searches and in the related videos sidebar. So we should be able to get direct more traffic to the tutorials, and hopefully that will mean more people participating, more people signing up for the forums. And that's what I want. So I hope you guys are enjoying the videos and everything, and it's just a little thing that I hope you can do for me here. And in case you're wondering, hey, what's in it for Billy? Well, I mean, besides making me feel good and furthering my own agenda here, things like more viewers and more likes and stuff like that, that generally gives me motivation to make more videos. So the more you guys comment and like the videos and stuff, the more I feel, hey, I wanna do more of this shit. So a vote for chili is a vote for more programming tutorials. And a dislike probably means I'm gonna have to sit by myself in a dark room, sobbing silently while masturbating to the Teletubbies. Goodbye!
Oh, you touch my tra-la-la. My ding-ding-dong.